statement, create table employees with those fields, and then I'm going to execute it here. So create table employees with the following columns: ID, full name, salary, and city. Okay. Of course, I know you guys you understand what is happening here because again, uh, so when I execute that, you can see the command has been completed successfully, and the table has been created successfully. The next thing I want us to do, I want us to insert the data. You can see we have these 5 employees. So John Doe, Patel, Jack, Jane, and then the final record. So we want to insert these records over here into the table, and then we're going to use this example. We're going to use this table with these pieces of data to understand the where clause better. So I'm going to copy this SQL query and have it here. So let me paste that here. Okay. And when I execute that, you will see 5 rows affected, which means we have successfully inserted 5 rows into our database. Okay. So if I want to confirm that, I can just use the select statement, select everything, which means all the rows from the employees table. So remember the table that I've created right now is the employees table. When I execute this query over here, you will see we have those 5 employees. They have been inserted into the database. So the ID, the full name, the salary, and the city. So selecting everything from employees, you can see it is returning all of those records: ID, full name, salary, and the city. Now let us see how we can use the where clause with the select statement to filter data. This is basically the syntax. You select whatever columns you want to select from whatever table you want to select, and then you pass your condition using the where clause like this. So for example, if you want to get all the employees who earn above 30,000, you can select whatever columns you want. Remember, we said we use asterisk. Asterisk basically means all the columns. Okay, not a good practice, but for now, because we are still learning, it's a good practice. Okay. So if you say here select asterisk, it means select all the columns from the employees table where, and then you can see we're passing our condition. And this is going to filter the records that are being returned by this select statement. Okay, it's going to filter the records that are being returned by this select statement. So if any given record matches this particular condition over here, then it will be selected by this where, by this where clause over here. So we use this where clause and then we pass our condition. So select everything from employees where the salary is greater than 30,000. So that is, for example, if you want to get all the employees who earn about 30,000. In fact, let us do that right now. So instead of selecting all the employees, we can say we want to select all the columns. Okay, we want to select all the columns from the employees table where, and then we pass here our condition. For example, we can say where the salary is greater than 30,000, like that. So I'm selecting here everything from employees where the salary is anything above 30,000, and when you execute that, you will see we're only getting the employees whose salary is above 30,000. You can see here the salary is 50,000, 35,000, 70,000, and then 65,000. Okay, we can even say here we want to get all the employees whose salary is above 50,000, and when we execute this, you see we're only getting the employees whose salary is above 50,000. So you can see we're using the where clause to filter the records that are being returned by this select statement. Let me go back to selecting all the employees. We can even select all the employees who come from a specific city. Let's say we only want to select the employees who come from Washington. So I can say here something like this: select all the columns from the employees table, employees, where, and then specify here where the city is equal to Washington. Okay, I'm supposed to put that as a string. So where the city is equal to Washington, like that. Okay, so select everything from employees where the city is equal to Washington. And now when we execute that, you will see they're only getting those employees who come from the Washington city. If you wanted, you could pass here, for example, something like Nairobi. Okay, and when we execute that, you see we get those 2 employees who come from Nairobi. So the thing is that whatever condition we pass here using the where clause, whatever condition we pass here, if that particular condition evaluates to true, then that particular record will be returned by your select statement. Okay, so whatever condition we put over here, if it evaluates to true, then the where statement is going to, the where clause is going to return that particular condition. And by the way, you can also use the and the or logical operators to combine multiple conditions. Okay, so if you go back to selecting one of our employees over here, okay, let's say we want to select all the employees who earn above 50,000 and they live in Washington. Okay, so you want to select all the employees who earn more than 50,000 and they live in Washington. So what I'm trying to show you guys is that you can use the and the or logical operators to combine multiple conditions in this where clause. So you can say here something like this. And by the way, we don't have anything like like that in SQL Server or like that in SQL Server. So for SQL, I believe, and even SQL Server, you're supposed to use an operator like that. And for the or operator, you're supposed to use the or operator like that. So if you want to select all the employees who come from Washington and they earn anything above 50,000, we're going to say here, select everything from employees where the city is equal, to Washington, like that, where city is equal to Washington, and the salary, and the salary is anything above 30,000. So 30, 1, 2, 3. So you can see here we're combining multiple conditions using the and operator. Okay, so the first condition is that the city is supposed to be equal to Washington, and the second condition is that the salary is supposed to be anything above 30,000. And of course, for that you can see we only have one record, which is this Jane Klaus. So Jane Klaus earns 70,000 from Washington. We also have another Washington over here, but the salary is not above 50,000, so that one will not be returned. Remember, whatever we have here is supposed to evaluate to true for the where clause to select that particular record. So now if we execute this statement over here, you can see when we get Jen Klaus, she's the only employee who satisfies these two conditions. She's the only employee who comes from Washington and earns a salary of greater than 30,000. And then if you want, you can also use the or operator. So copy this and paste it here, and you can use the or operator. So in this case, if any of these statements returns true, okay, both of them don't have to be true. If any of them returns true, then the where clause is going to select it. So if you come from Washington, you will be selected. Or if you want anything above 30,000, you will be selected. And if we execute that, you will see it's almost like all of them, because yeah, all of them are satisfying at least one of those conditions. You can see for the first one, it is satisfying the condition of coming from this Washington city, but of course not satisfying the salary condition. And then all the other ones, they satisfy the condition of the salary being greater than 30,000. So that is the where clause in the select statement. We use it to limit, or rather to filter. This is what we refer to as filtering. We use it to filter records from our database. Okay, that is the where statement with the select clause. We can also use this where statement with the update clause. Okay, so you can use the where clause. Sorry, you can use the where clause with the update statement to update data. So this is the syntax: update, and then the table name, and then you set whatever column is equal to the new value where a certain condition has been met. You can see here we are updating the employees table, and we are setting the salary to be equal to 150,000, where the city is equal to Washington. Okay, so we are updating the employees here, and we're setting the salary to be equal to 150,000. So we're setting the salary column to be equal to 150,000, where the city is equal to Washington. So if a record matches this particular condition over here, okay, if a record matches the condition of a city being equal to Washington, then the salary is going to be set to 150,000. So let us have our own version of this update statement. Let's say we want to update the salary of John Doe to go from 30,000 to, let's say, 40,000. Okay, so that's going to be very simple. You can just look for something that will make John Doe unique, and that is going to be the ID. So I can say here, update employees. Okay, you want to update the employees table, and you want to set the salary. You want to set the salary to be equal to 40,000, 40, 1, 2, 3. So remember, we want to update this salary column over here for John Doe. So you want to set the salary to be equal to 40,000, and then we pass here our condition using the where clause. So where, and then we can say here where the ID is equal to 1. So any any record whose ID is equal to 1 is going to receive this particular update over here. It's going to receive this update of the salary being equal to, being set to 40,000. Now, if we execute this, I want you to look at this right now. The John Doe record has a salary of 30,000. But if we run this update statement, if we execute the update statement, you can see it was a success. And now if we go back to selecting everything from employees, you can now see John Doe has a salary of 40,000. Okay, and this update statement, of course, it can affect multiple rows. So for example, you can say here, update employees. So you want to update the employees table. Again, guys, SQL is not case sensitive. So even if I wrote employees in all lowercase, it will still work. So update employees, set salary to be equal to, let's say, 90,000, 9123, where the city is equal to Nairobi. So for Jack Kimani, who is from Nairobi 35,000, and Ken Oduor, who is from Nairobi 65,000, their record is going to be updated when we say here, where city is equal to Nairobi, like that. So we are updating the employees table, and we are setting the salary to be equal to 90,000, where this particular condition over here is met. So if your city matches Nairobi, then the salary is going to be updated to 90,000. Now, if we execute this, you can see two rows have been affected. And when we say select everything from employees, you now see we have 90,000 from Nairobi here. You know, the update statement was a success. Okay, and of course, if you want, you can also pass, compound conditions like this. For example, where city is equal to Washington and salary is greater than 30,000, all of that is going to work perfectly fine. Okay, that is the where statement with the update. That is the where clause with the update statement. And then finally, let us look at the where clause with the delete statement to delete data. So we can use the where clause in a delete statement to restrict which data gets deleted. And this is the syntax: delete from your table where a specific condition has been met. Guys, you can see how SQL is very simple. It is just one or two things changing. So let's say we want to delete all the employees coming from Washington, okay? Or let's say we want to delete all the employees earning less than 50,000. Okay, so you want to delete all the employees earning less than 50,000. So I can say here, delete from employees, where, so we are passing here our condition using the where clause. So delete from employees where, and then specify here where the salary is anything less than, let's say 30, sorry, we have said 50,000, 50, 1, 2, 3. So this statement over here is going to delete all of those employees who earn anything less than 50,000, of which in this case is only one employee, and that is John Doe. So John Doe is going to be deleted, and if we execute this statement over here, if we execute that statement, we can see one row was affected. And when we go back to selecting all of the employees, you now see John Doe has been deleted because John Doe had a salary of less than 50,000. So this is the delete from clause. So delete from employees where, and then where the salary is anything less than 50,000, and you can see that has worked perfectly fine. Do we have any questions up to that point? Any questions? Okay, if there are no questions, let us proceed. The next clause is the order by clause. The order by clause in the SQL Server is used for sorting data in either ascending or descending order of a query based on a specified column or a list of columns. Okay, I think we all understand what we mean by sorting data. So sorting data is arranging data in a specific manner, either ascending or descending from let's say, okay, I think we all understand what we mean by sorting. So that means that if you want to sort the output or result of a query in ascending or descending order, then you're supposed to use the order by clause in the SQL Server. Whenever you want to order your data, whenever you want to sort your data either in ascending or descending order, you're supposed to use the order by clause in the SQL Server. Sorry. By default, the order by clause in the SQL Server will sort the data in ascending order. So if you don't specify the direction, whether it's ascending or descending, then by default it's going to be in ascending order. And the keywords for the order by clause are the keyword parameters for the order by clause are ASC, which means sort in ascending order, and DESC, which means sort in descending order. Okay, so the order by clause can be applied to any data type in the column table. Even if you want to sort based on, let's say, the first name, the last name, it's still going to work perfectly fine. So let's use the same example for the employees table. I'm going to get the same table. Let me start by dropping the current employees table. So drop table employees. Okay. So if we execute that, you see that the employees table has been deleted successfully. Okay, and then now I want to replace the same table, so I can paste that query over here. So create table employees. You can see we have the ID, the full name, the salary, and the city. And when we execute this, you see the table has been created successfully. Okay, and then let us insert the data, the same pieces of data that we had previously, and then we will use that to understand this order by clause. So you can see 5 was affected, which means we have successfully inserted 5 records into our table. And if you want to confirm that, we can say here, select all the columns from the employees table. So select all the columns from the employees table, and when you execute this, you see that we end up selecting all the columns from our employee table, and that's perfectly fine. Now, if you want to sort, let's say based on the salary, you're supposed to use the order by clause. Okay, so you can just, this is the syntax. You're supposed to say here, select everything from, and then that particular table, in this case, the employees table, and then you specify the order by clause on which column. So you can say here, order by, and then you say here, for example, salary. Okay, so select everything from employees, order by salary. And we have said, if you don't specify the direction, either ascending or descending, by default, the order is going to be ascending. By default, the order is going to be ascending. Okay, so right now, if I execute this query over here, you will see that we are sorting this in ascending order. So a salary of 30,000, 35,000, 50,000, 65,000, and then 70,000. That is being sorted in ascending order. That is the default order. But if you want this to be sorted in descending order, you're supposed to use the DESC keyword. DESC. So DESC stands for descending, and if you want to sort in ascending, you're supposed to use ASC. So ASC is equivalent of ascending, and that is the default one. You can see it's just the same thing. But if you want to sort in descending order, you use DESC. And when we execute this, you see that we are sorting our salary column over here in descending order. And guess what? It doesn't apply only to numeric fields. You can also use this order by clause, or let's say, string fields. For example, here we can sort by, we can order by city. So select everything from employees, order by city in descending order, and when we execute that, you now see we are ordering here by the city. Okay. Is it really? I believe it's working. Yeah, because it's M, N, and then all the way to W. So if we do the reverse, it's working. So you can see Washington, and then Nairobi, and then Mumbai. And if we specify here ASC for ascending, then it will also be sorted in ascending order. So Mumbai, Nairobi, and then Washington, and then Washington. And again, guys, remember, if you don't specify here the order, by default, it will the order by clause will sort in ascending order. That is only when you don't specify the order. If you don't specify the order, the default order is going to be the ascending order. And then, of course, if you want, you can use DESC for descending. And then you can also sort by multiple columns, but I don't really advise doing that, guys, for now. Okay, so I don't really advise sorting, or ordering by multiple columns. The next that we have here is the top n clause. So the top n clause in SQL Server is used to specify the number of data rows to return. Okay, so the top n clause in SQL Server is used to specify the number of data rows to return. So in large table with thousands or even millions of data rows, it may take more time to return all the records, which can cause database performance issues. So you can imagine if you have a database containing billions of records, something like Instagram, okay, they have, let's say, billions of reels, or maybe trillions, probably trillions of reels in their database. So if you run this particular SQL query to just select everything from that particular table, then it's going to take forever to basically fetch all of those records. So usually it's a good idea to do something called pagination. So pagination is where you just select only a bunch of those records. Let's say if you have 100 records, instead of selecting all of those, 100 records, you only select like top 20 records, or maybe you only select like 20 records and send them to the user. Okay, and then if the user wants more records, they click on some sort of a button and then you fetch the next 20 records. After that, you fetch the next 20 records and so on and so forth. So that is the work of this top n clause. It is used to specify the number of data rows to return from that particular table. And you're saying in large tables with thousands or even millions of data rows, it will take more time to return all the records, and this is going to cause database performance issues. So to fix this problem, we can return a specified number of rows from a table using the top n clause in SQL Server. Okay, so to fix this problem, we only return the specified number of rows from the table using the top n clause in SQL Server. So for that, we still use the same example, but now we have more pieces of data. So I'm going to copy this here. Okay, I'm going to copy that, and then we start by dropping the table. So drop table employees. Again, guys, SQL is not case sensitive. Okay, and this is true for all the standards. Any relational database management system, like PostgreSQL, Microsoft SQL Server, MySQL, Oracle DB, all of those relational database management systems, they follow this SQL Server, and we say SQL is not case sensitive, which means writing this and writing this, drop table employees, and writing this, drop table employees, is one and the same thing. All of those are going to work. Okay, but usually the convention is that we write the SQL commands in uppercase, and then we write our own keywords, or rather our own identifiers in Pascal case or snake case or camel case, whichever one we want to work with. But either way, this would still work. You can see the command has been completed successfully. We have dropped the table successfully. So here, I want to create the same employees table. So create table employees, and as you can see, the table has been created successfully. And then I'm going to insert all of this data. So inserting to employees, we have the ID, the full name, the salary, and the city, and these are the values. So John Doe, Washington, NM Patel, all the way to the 40th record. So if we paste this here and execute that, you see 40 rows affected. We have inserted 40 pieces of data into our table. Now, if I was to say here, select everything from employees like that, we will see that we have all of these 40 records. Okay, but again, guys, we usually want to do something known as pagination. We don't want to select all of the records at once. We only want to select those records chunk by chunk. Or rather, we only want to get those records chunk by chunk. We get maybe the first 20 posts, or the first 20 records, or the first 20 whatever, and then you send them to the user. Okay, if the user wants more records, they can click on a certain button, or maybe refresh that particular page, and then refresh the next 20 records. That is very important for database performance. So this top n clause is what you use to perform just that. And this is the syntax. You use select top, and then you specify the number of records that you want to select. And then you specify the columns you want to select, and then from whatever table it is you want to select. For example, if you want the top 15 records, you select top 15 like that. And then you specify the columns, of which asterisk means all the columns, and then you specify here the table that you want to select from. So let us select here, let's say the first 10 records, or rather the top 10 records. Now, to do that here, we do select top, and then you specify here, for example, 10, and this is going to get to the first 10 records. And then after that, you specify the columns that you want to select. Okay, so if you want all the columns of of which in this case I want all the columns. I'm going to select all the columns and then specify the table. So from employees like that. So select top 10. This is top 10 records, and then specify the columns, of which in this case we want all the columns from, and then the employees table. And of course, when we execute that, you see we only get the first 10 records. Okay, and again here, if you want, you can pass the columns that you want. We can say, for example, we only want the full name and the salary. Okay, as you can see here, we're specifying we only want the full name and the salary. In this one, let me see, execute that. Yeah, you can see we only get the full name and the salary. Okay, if you only want the full name, then that is how we do it. Select top 10, and then we only want the full name column from the employees table. And when we execute that, you see we only get the full name. So for now, I want all the fields. So I can specify here, I want all the fields. And when I execute that, you see we get all of this. Okay, and guess what, guys? You can also pass here our filtering. You can say here, for example, select the top 10 from employees where, let's say, the salary is anything above 50,000, 50, 1, 2, 3. So you can see we're now coming up with more complex queries. Select top 10 records, and we want all the columns from the employees where the salary is above 50,000. And when we execute this, you see now we are getting the top 10 records where the salary is greater than 50,000. Of course, we have more than 10 records with a salary of greater than 50,000. But in this case, we are only selecting the top 10 records where the salary is greater than 50,000. So that is something that you guys should just, should look into. You can also use this top M with order by clause. Okay. So for example, here we can say select top 10 from employees. Okay. Again, my cursor has disappeared. Let me just specify here a new query. I don't know why sometimes why it behaves like that sometimes. Don't save. So select top 10 records from employees. Okay. And then you can say here, for example, order by the salary column, like that. So select the top 10 records from employees, order by the salary column. And when we execute that, you will see that we are getting them ordered in ascending order. If we want, you can specify here DESC to order them in descending order. So select the top 10 records from employees, order by the salary in descending order. And of course, when you execute that, you now see we are ordering them in descending order. Okay. And yeah, that is working perfectly fine. So select the top 10 records from employees, order by salary in descending order. The next one here, the next level of this top is with the percent. So you can also specify the percent keyword, and it's going to select the top, whatever that is, percent. So you can also use percent in SQL Server. You can also use the percentages. SQL Server will return that percentage of the total rows. So for example, in this case, we can say we want to select the top, let's say 50%, so top 50, and then we specify here percent. So the percent keyword, so top 50%. And then you specify the columns that you want. In my case, I want all the columns, okay? And then from the table, from employees, like that. Select top 50% from the employees, and that is going to return the top. I think we have 40 records, okay? So this is going to return the 20 records. When you execute that, you see we indeed get 20 records. And of course, if you want, you can also pass more complex clauses. You can say here, for example, where the salary, okay, I want to just use this in Pascal case, maybe where the salary is above, I don't know, let's say 50,000, 50, 1, 2, 3. Okay, so select 50% from employees where the salary is above 50,000, and when we execute that, you can see, of course, it doesn't get to 20 because we don't have 20 of them where the salary is greater than 50,000. And guess what? I can also add the order by clause here. Order by. Anyway, guys, whenever your queries are getting too long, you can always go to a new line. So we can say here, for example, select to 50% from employees where the salary is above 50,000, and then order by that particular salary column, maybe in descending order, like that. So all of this is a valid SQL query. Even if you're putting new lines, it's going to work perfectly fine. It's usually good when it comes to organization. And when I execute that, you see now we are getting all of them ordered in that particular order. But the key thing here, you don't even have to understand all of this where salary is greater than 50,000. The key thing you need to understand here is that we can use this percent keyword over here. So in such a case, whatever number we have specified here is going to be percentage in terms of that particular number. So 50% of the total goes. And when we execute this, you see we get those 20 rows. Next, we can also select percent with ties. So with ties, we'll tell SQL Server to include additional rows that have the same value as the last one returned. Okay, let me see if this is going to give me what I want. Let me start by copying this previous command. There is something I want to check first of all. So select everything from employees, order by salary in descending order. Okay. This one only. Select everything. Select top 15% from employees, order by salary in descending order, and then select everything from employees. There is something I want to confirm first of all, guys, before we proceed. So you can see here, Naomi Tanaka earns 69,000. Let us see if we have any other employee who earns 69,000. It will help me to drive the point home. Okay, so select everything from employees where salary is equal. Is that a question? Is somebody asking a question?
Can you please explain that? The top percent thing.
Yes.
Yeah, the previous.
But we've just done that one like 2 seconds ago. Okay, we said we use percent to select us a percentage. So here is going to be top 15%, like that. And then of course this is just the order by clause, order by salary in descending order. There is something I'm trying to look at. I'm not sure why I'm not getting it. But either way, this top with ties, it's used to tell SQL Server to include additional rows that have the same values as the last one returned. Basically, when I run this query over here, okay, when I execute this query over here, you can see we have Naomi Tanaka from Tokyo who earns a salary of 69,000. Okay, but you might be having another row coming after Naomi Tanaka with the same 69,000 value, maybe 2 or 3 of them. Okay, so if you also want to include those rows, okay, that have the same value in the salary, for example, or just time in terms of any column, then you use this top whatever percent, and then you specify here with ties. And what this is going to do is going to select all of those as much as it is going to select the top 15%. It's also going to select all of those records that have tied. I don't know if I'm explaining that in a way that you get understanding it. Because again, sometimes you might find that the record, when we executed this top 15%, let me just first of all remove this with ties. When we executed this top 15%, maybe there was a record that was very similar to this Naomi Tanaka in terms of maybe let's say the city or maybe the salary. Okay, so this with ties over here, it's used to, also bring those records that were tied in one way or another. Let's see if this is going to give us that. Execute this. Just a second, guys. With ties. Why is it not? Let's see if this is going to give us anything. New York, Washington, we have 6 records. All the way to Naomi Tanaka. And then when you pass here with ties, but okay, I really wish I had a good example. Would have used that to show you that in detail. And then, yes, and then you can also use this top with the update and the delete statement. I don't think I need to go through that. So you can update the top end records and then set the column to be equal to value. Okay, so in this case, we can say, for example, let me first of all start by saying here, select everything from employees. And when we run that, you see we get all of those employees. So we can update top end records. So you can say here, update top, let's say 15 records. We want to update top 15 records, and we want to set maybe the city to be equal to, I don't know, we can say here Kisumu or something in those lines. So update the top 15 records, set the city to be equal to Kisumu, and when you execute that, incorrect syntax, I think it's supposed to be update, wait, what am I using here? Oh, yes, we are forgetting the table name. So update top 15 and then we specify here the table name, employees. Update top 15 and then we specify the table name, employees, set city is equal to Kisumu, and when we execute that, you see 15 rows have been affected. So when we go back to selecting everything from employees, you now see the top 15 records, they all have a city, the city column is set to Kisumu. And then if you also want, you can also delete using this top keyword. For example, you can delete the top 15 records. So delete top 15 from employees. So you can imagine, okay, let me first of all execute this. So delete top 15 records from employees. When you execute that, you see 15 rows have been affected. And when you go back to selecting everything from employees, you now see you're starting from 16 all the way to the last one. Okay, so this one here, you can imagine, for example, you have some sort of, logs or something. You can delete the top, whatever logs from that particular table, and yeah, it will work perfectly fine. Do we have any questions up to that point? Come again? With ties. So what I was saying is that when we select top, let's say here now, if I go back to saying select top, let's say 15 from employees. When I say here select top 15 from employees, it's going to return the top select top 15 and then all the columns. So select top 15, all the columns from employees. It's going to select the top 15 records. So you can even say here maybe 5. It's going to select the top 5 records. Okay? But usually sometimes in the process of that selection happening, maybe the next record that was coming immediately after this Emily Carter, for example, maybe they had a similarity, maybe for example in salary, or a similarity in this city column over here, for example. So if the record coming after the last record, when we run the select of whatever from that particular table, if the record that was coming immediately after the last record had a column with a value similar to this particular record over here, then it will also be included, even if it's not among the top 5. Okay, so if let's say we had John Doe coming after Emily Carter, who also has a salary of let's say 90,000, then as much as John Doe is not among the top 5, he will also be selected when we use here with ties. That is if they have any similarity in any of these columns with the very last row. Does that make any sense?
No. So yeah, then so it's going to ignore the number.
Yeah, it's going to ignore the number as long as whatever is coming after has something in similarity to this, let's say the salary column or the city column. Okay, so if I execute this, whatever the column corresponding to that, because okay, select, you know what, let me just do this. Maybe we can use this to understand. Select everything from employees. Okay, and then maybe let us say here, order.
To make things worse, napata youth silly kwa hata kama una cheat ni sawa, hata kama una cheat ni sawa. Na unanidharau aje hiyo design? Unaacha used condoms kwa dustbin.
English name?
English name yangu si Saya, S-A-Y-A.
So of course you know this guy.
That guy aje.
Which guy?
Si utakuta labda ni bro yake
Someone who asked you, can I come over? Ukasema Z, not in the mood, Tom. Yes, the sex was great and you are perfect, of course, but I don't think we shall do it again. And by the way, you are the only one who has made me squirt out of all the 4 men I ever dated. Did I do anything wrong? Because I was just beginning to fall.
So, maybe let us look here for this one in Nairobi. Okay, so let's say you want to select the top 11 records. You can see what is coming after is also Nairobi. Okay, so you can see what is coming after is also Nairobi. So let us select the top 11 records. We should go all the way to Japhet Otieno. Okay, so select top 11 records from employees and then order by city in descending order. And when you execute that, you see it goes all the way to Japhet Otieno. And then when you say here with ties, you can see it was going all the way to Japhet Otieno, Nairobi. But when you say here with ties and execute it, you will see it now goes beyond Japhet Otieno, because also Elijah Njoroge was also coming after Jacob. They were tying in terms of this particular city over here. Okay, you know what? Let me first of all remove this with ties. And even this top statement, let me remove all of them. So if we say here, select everything from the employees and execute that, you can see all the way to Japhet over here, record number 11. Japhet is from Nairobi. And then the record after Japhet, which is Elijah, is also from Nairobi. And then the record after Elijah, which is Angela, is also from Nairobi. But let's say we select the top 11 records. So top 11 records will go from the first one all the way to Japhet. Okay, it will go from the first one all the way to Japhet. And as you can see, when we select that, it will go from the first one all the way to Japhet, but Elijah and Angela, they are also tying with this Japhet under the city column. You can see Nairobi, Nairobi, Nairobi. So if we say here, select top 11, okay, the cursor has gone away. I don't understand what is happening with this. If you say here top 11 records and you execute that, you can see we go all the way to Japhet. We go all the way to Japhet Otieno. But remember, we had records coming after Japhet Otieno that were also from Nairobi. So when we say here with ties, that is now the work of with ties. Okay? If the records coming after were also tying in terms of whatever columns we're using here to order by or anything in those lines, then those particular columns would also be selected. So it's going to ignore this number 11 over here. It's going to select all of those records as well that are coming after Japhet if they were tying in terms of the city. So if we execute this one here now, execute that, you now see, yes, we are selecting here top 11 records, but because we specified with ties, Elijah Njoroge is also tying with Japhet in terms of, the city, and even Angela is tying with Japhet in terms of city. They are also being selected in this top statement. Does that make sense now? Does that make sense? Yeah. I don't understand this bug where the cursor goes away. If I can't see the cursor, I don't even know what I'm typing. Okay, you can see here, guys, when I'm typing and you can't see the cursor, it's so boring and so weird. But at least when you see the cursor, you can be able to see where I'm typing. So whenever you see me selecting new query, because the cursor has disappeared for some reason. Okay, so I hope we now understand the top end clause in SQL Server. The next clause that I want us to look at is the group by clause. So the group by clause is used to aggregate rows that share the same values in specified columns. Okay, so basically what we mean by that is grouping data into buckets, so you can perform aggregate functions like count, sum, average, mean or max, and so on and so forth. So let's say you want to count all the employees who earn above, let's say, 30,000. Okay, so you can use this group by clause to group all of those employees who earn above 30,000 and then pass them to an aggregate function, for example, count or sum or average or minimum or maximum. Okay, if you want to get the summation of the salary of all the employees who earn above 30,000, you start by grouping them using the group by clause, and then you use an aggregate function. So this group by clause is typically used together with an aggregate function. So we are going to use the same employees table with the same massive amount of data that we had. So I'm going to copy this employees table and have it here, but I need to start by dropping the previous table, the previous employees table. So drop table employees, yes. And if we execute that, it will drop that employees table and create this new one over here. And then we want to insert this data. So copy that query over there and paste it here. And when we execute that, you can see 40 rows have been affected. We have inserted 40 pieces of data into our table over here. So let me backspace that, and then now we start learning about this group by clause. So the basic syntax for the group by clause is you select the column name that you want to group with. Okay, you can see what column names, it's a specific column name. And then you pass that particular column name to any aggregate function. So when you say aggregate function, it could be a function like count, okay, sum, average, minimum, and maximum. At your own time, you guys can go look into aggregate functions. Otherwise, I'm also going to continue working on this documentation. You also have, rather these notes, you also have aggregate functions, as a topic. And then you specify it from whatever table it is, and then you group by that particular column. So for example, you can see in this case, we want to group employees by city and count how many employees are in each city. Okay, we want to group employees by city and count how many employees are in each city. So because it is city that you want to work with, you want to select that particular city column, and then we're passing that to the count aggregate function from the employees table group by city. So if we copy this and have that query here, execute that, you now see we are getting for example, Beijing, we have 2 employees in Beijing, we have 1 employee in Chicago, 1 employee in Doha, 1 employee in Dubai, 2 employees in Eldoret, 3 employees in Kisumu, and so on and so forth. Okay, so select city, count, and then you're counting that particular selection, and then from employees group by city. Okay, and then by the way, as you can see, where is that? I'm kind of lost. Okay, yeah, here we are. If you want to count employees by city and count, okay, if you want to group employees by city and count how many employees are in each city, then we're supposed to use this query over here. Select city and then count whatever that is from employees and then group by city. As you can see, the value we are getting here, the result we are getting, you can see it doesn't have a column name. We only have city, okay, and then here we have no column name. If you try to look at this closely, you see here we have no column name. So you can use the as keyword to provide an alias to that particular column. So you can say here count everything as, and then we specify the column name. So you can say here, for example, employees, or you can say here number of employees. So you can see for now we are getting here no column name, but if we execute this now, we now get here number of employees. So we are using this as keyword to provide the column alias. Okay, select city, count those records as number of employees from the employees group by city. I know you've not yet understood that, but we'll keep looking into that. So yeah, we'll keep looking into this. I hope you guys will have a basic idea of what this group by clause does. For now, you're not really using it that much for now, but of course at one point it's going to be extremely important. Do we have any questions on that point? maybe guys at your own time you can go look at the halving clause. At your own time you can go look at the halving clause. Let's take a 10 minutes break. And then we come back at exactly 10:35. So some. operator. So in SQL Server, we have the following operators. We have assignment operators, we have arithmetic operators, comparison operators, logical operators, and set operators. Okay, I've not yet finished documenting set operators, but you're going to find them here once I'm done with them. So the first category of operators is assignment operators, or maybe the assignment operator. So the assignment operator in SQL, this equal symbol over here, is used to assign the value to a variable. So the assignment operator is used as follows. We use this assignment operator to assign a value to a variable. Yes, we also have variables in SQL Server. Okay, we also have variables in SQL Server. I'm not sure if it's an SQL standard. Maybe you can go do your own research. But when it comes to SQL Server itself, yes, we have variables there. So let us look at this. Let us look at how we can use this assignment operator. The first one is insert and select statement. So the assignment operator is mostly used to assign values to a variable. So you can see here, we're declaring a variable called age, which is of integer data type. And by the way, guys, you don't have to understand anything to do with variable declaration. This is quite insignificant for now. So for now, this is quite insignificant, but as time goes by, maybe you might need it in one of your projects. So we're declaring here a variable called age, which is of the integer, and we're setting a value of 25 to that particular variable. And as you can see, we're using the assignment operator. Okay. By the way, as I'm telling you guys, this concept of variables in SQL for now is quite insignificant. In fact, I'm just going to copy this code over here and have it in SSMS to just use it to explain what it is I'm explaining here. So as you can see, we're declaring a variable called age, which is of type integer, and we're setting a value of 25 to that particular age variable. So set age is equal to 25, and when you say here select age, you're supposed to see that particular value of 25. So when you execute this here, you see we get 25 here. And here we're getting no column name. So I can just say here, I can specify here an alias as, maybe you can say here user age or something in those lines. And when we execute that, you now see here user age variable is 25. Okay. So when we select here the age, you can see we get the value 25. So again, we're declaring a variable called age of this integer data type, and you are assigning a value of 25 to that particular variable. That is the reason why when you executed here select at age, it gave us this value 25 over here, and that worked perfectly fine. So that is how you use set to assign values to a variable. Okay. Now, in the above example, we're declaring a variable called age and assigning a value to which a value of 25 using the set together with the assignment operator. Yeah, I think I've already explained that. And then you also use it in update statements. So set salary is equal to the new value. I think you guys saw us doing this all the time. So set salary is equal to the new value where, you know, a particular condition. So update that particular table, set salary is equal to, and there we are using the assignment operator. So set salary is equal to that particular value where, you know, a particular condition is being met. Okay. Let us just try to see whether our employees table has something we can work with. So select everything from employees, and when we execute that, you can see we get this employees. So let us update John Doe, for example, to have a salary of let's say 90,000 or 100,000, and for that we use the assignment operator. So update employees table, update employees, set salary is equal to let's say 100,000, and as you can see we're using the assignment operator. So set salary is equal to 100,000, where, for example, the ID is equal to 1. That. And when we execute that, you can see one row affected. And when we select everything from employees, you can now see John Doe has a salary of 100,000. And that is what we perfectly fine. Okay. So yeah, that is it about it. And then we have the variations of the assignment operator. And now this is the reason why I was telling you guys the good thing about programming is that as you keep running programming, it keeps getting easier. So you guys, you know this from JavaScript, the addition assignment operator. So I hope you know what it does. Subtraction assignment operator, multiplication assignment operator, okay, modular assignment operator, and so on and so forth. So at your own time, you can go try work with them. And even arithmetic operators, I believe they're very much similar. There's nothing to go through here. So plus is for addition, if you want to add two numbers. This one here is for subtraction. We have this one here for multiplication, division, and modulo. So this one is class 2 mathematics, and I will even give it in JavaScript hundreds of times. So you can see we have these examples. Allow me to copy them and have them here. Okay. So if you say here select 100 plus 300, we get a value of 400. 100 and 300 will get that particular value. And then you can see how I'm writing comments in SQL Server. Okay. You can see how I'm writing comments. And I believe this is a general SQL standard. If you want to write comments in SQL, this is how you do it. So if we execute all of that, you can see we get all of that. So for 100 plus 300, we get a value of 400. For 100 times 300, we get that particular value. For 100 minus 300, we get this. Okay. For 100 modulo 200, for 100 divided by 200, we get 0. And then for 100 modulo 200, we get 100. So modulo is going to give you the remainder. Okay, that is it about arithmetic operators. I don't think there is anything complicated about that. Okay, so maybe you get at your own time. You should try to look at this. And then we can also use these arithmetic operators on date and time values. Okay, so when you execute get date gives you the current date. So you can add, for example, 10 days to it, and then you will get 10 days to it. If you want to see what 10 days ago was, you can use get date minus 10. So for example, if a user, let's say, I know you guys, maybe you have Netflix subscriptions or you have Spotify subscriptions. Okay. So if a user pays today, maybe their next payment is supposed to be in 30 days. Okay. So maybe let us try to use this actually, so that you can see what you're talking about. You can say here, select get date plus, let's say, 30. So get date will give you the current date. If I just say here, select get date, this get date function in SQL Server is going to give you the current date. You can see it gives us the current date. So if you had here, if you look here, get date plus 30 is going to give you 30 days from today. If I execute that, you see, we get that days from today is going to be the 11th month, date 20, and so on and so forth. And then you can even give it an alias here. So select get date plus 30 as next payment date. Okay, so maybe if you're building Netflix or anything in those lines, and the user has paid today, so it makes sense that their next payment is supposed to be 30 days from today, even if it is 45, and so on and so forth. So when you execute that, you now see for this user, the next payment date is going to be 2025 11 20. So the 20th day of the 11th month of 2025 at 10:44, whatever that time is. So yeah, you can also use that, and you can even say here, get date minus 30, and this is going to give us the date 30 days ago. So you can say here as previous payment date. Executing that, we get it was the date 21, the 9th month of 2025, date 21, and that is working perfectly fine. So yeah, you can go look into that at your own time to understand them even better. And even comparison operators. So the comparison operators in SQL Server are used to compare two values. Okay, so the result of a comparison can be true, false, and I don't really like this. I'm not sure if it is an SQL standard, but they also have another one here, unknown. I'm not really a big fan of that. For me, and I think for most of us, we are used to this comparison of operators evaluating to a boolean, either true or false. But in SQL Server, I'm not sure if this is an SQL standard, but I believe in SQL Server, they've also introduced this unknown. Okay. To me, I don't think it's a really good idea, but either way, SQL Server So in JavaScript, for example, if you compare 10 greater than 20, in JavaScript you either get true or false. But in SQL Server, it could be true or false or unknown. Okay, so an operator that has one or two null expressions basically returns unknown. I really wish they had a way of just making it return either true or false. And instead of false, maybe just, instead of unknown, it just returns false. But either way, we want people to get. Okay, so you can use comparison operators on all expressions except expressions of type text, and text, or image. So you can use comparison operators with dates, you can use them with decimals, you can use them with integers, but you cannot use them with text, and text, or images. Okay, you can even use these comparison operators with char and varchar, but you cannot use them with these data types over here. So remember we say text is basically very similar to text, only that it is Unicode, it supports Unicode characters. So here are the types of comparison operators in SQL Server. We have the equal operator, which basically returns true if the operator on the left is equal to the operator. Sorry, if the operand on the left is equal to the operand on the right. I don't need to go through that. This is very basic from JavaScript and even, I don't know, class form mathematics or something in those lines. And then we have the not equal operator. So the not equal operator is denoted like this, not equal, or you can also use this symbol over here. So this symbol here, as you can see it, is also used to denote the not equal operator in SQL Server. In fact, let's just go through them one by one. We can select all the employees. Let me just first of all start by selecting all the employees. Select everything from employees. Okay. So if we run that, we see we get all of those employees from 1 all the way to 14. So we can select here all the employees where, and then for this where condition, this is where we'll be looking at those comparison operators. I can say, for example, where city is equal to Nairobi. Okay, so remember this where clause, it will select a record for which this condition over here has been evaluated to true. And this comparison operator, okay, sorry, this equality, did we call it equal operator? Yeah, it returns true if the operator on the left is equal to the operator on the right. So in JavaScript, it was something like this, okay, but in SQL Server, we don't have it like that. It is just a single equal sign in SQL Server, and I believe in SQL in general. So if we were to execute this, it will return only those employees who come from Nairobi. And then the next one is the not equal to operator. So the not equal to operator will return true. It will return true if the operator on the left is not equal to the operator on the right. Of which in this case, this query over here will return all of those employees who don't come from Nairobi. If we execute that, you will see we'll get all of those employees who don't come from Nairobi. Okay, we are getting all the employees who don't come from Nairobi. And we'll say that we can also use something like this to mean not equal to. Okay, so this is also a symbol to denote not equal to in SQL Server. And if we execute that, we basically get the same thing. I prefer we follow the standard of this one over here, not equal, because it is easy to understand from our basic programming knowledge. And then we have the next four: greater than, less than, greater than or equal to, and less than or equal to. I think we all understand what we mean by that. So you can say here, for example, we want all the employees whose salary is anything greater than, let's say, 50,000. Okay, so this one here will select all the employees who earn above 50,000. As you can see, we get all of them. And then we have the next variation, which is greater than or equal to. Okay, you can see for now, the greater than did not get any employee who earns 50,000. It was only getting all of those employees who earn above 50,000. So greater than or equal to will return all of those employees who earn 50,000 and above. 50,000 included, of course. And when you execute that, you can see we have NM Patel, who was not there previously. And then the exact opposite of that is less than. Okay, I don't need to explain what that does. If you don't know what that means, seriously, there must be a very huge problem with you. So less than, and and then we have less than or equal to. And then we execute that, you see, even n pattern is also included because of that less than or equal to. And then we have the weird ones. So I don't understand if this is SQL standard or if this is just SQL server adding their own operators. So you have the not greater than and the not less than. You can see how they get weird. Not greater than operator and the not less than operator. In fact, I'm not going to go through those two operators. I think we get an idea of what maybe they do. Okay. Do we have any questions at that point? Let us look at the logical operators. So the logical operators in the SQL server are used to test for the truth of some condition. Okay. So the logical operators in the SQL server, they are used to test for the truth of some condition. So logical operators, like comparison operators, return a Boolean data type with a value of either true or false. And in SQL server, we have the following logical operators: the AND logical operator, the OR logical operator, and the NOT logical operators. And guys, these logical operators, they work the same across all programming languages. Okay? They work the same across all programming languages. It doesn't matter what you're working with, the logical operators are always the same. The AND logical operators will always return true if the operands on both sides are true. I mean, if the operands on both sides evaluate to true. The OR logical operator will always return true if either of the operands is true, otherwise it returns false. And then the NOT logical operator, which reverses the value of any other Boolean operator. So this NOT is used, it's like a switch. If something is on, it switches it off, and if something is off, it switches it on. So that is the NOT logical operator. So the first one here is the logical AND operator, which, as we have said, it compares two Boolean expressions and it returns true when both the conditions are true and returns false when either of the conditions is false. So in this case, let me just try to first of all get all of these employees because I want us to see something. I want to get all the employees where the city is equal to Nairobi, because I want us to first of all go very slowly here. Nairobi. Yeah, like that. So select all the employees. So select everything from employees where city is equal to Nairobi, and when we execute that, you see we have all of these employees. Now, what if we want all the employees who come from Nairobi and they earn anything 40,000 and above? Okay, so that is why we use the AND logical operator. So AND, their salary is greater than or equal to 40,000. Okay, so the first record over here will fail the test because the salary will return false. You can see for the salary here, the salary is supposed to be above 40,000. So 35,000 is not greater than 40,000, so that will return false. Next, we have 65,000 Nairobi. This one here will be evaluated, will be selected, because you can see this compound statement over here will return true for that particular record. It is checking everything. The city is equal to Nairobi and the salary is above 40,000. Same thing to them, to Grace Wanjiro and Angela Mwandi. So if you were to execute this now, you can see we filter that even further to get all the employees whose salary is anything above 40,000 and their city is Nairobi. Okay, and then we have the NOT operator. So the NOT operator is used to flip the logic on its head. Okay, so this one now will return like the inverse of what we have here. If we go back to just selecting all the employees who come from Nairobi, just a second, guys. I want to show you something. If we go back to selecting all the employees who come from Nairobi, I now want to flip. I want to flip the logic for this salary being greater than or equal to 40,000. And to flip that, I use the NOT operator. Okay, so we start asking ourselves, is this salary greater than 40,000, 35 greater than 35,000, greater than 40,000? That is false. And then this NOT operator over here will flip that particular logic to true. So this first record over here will be selected. This second one over here will not be selected because a salary of 65,000 greater than or equal to 40,000. Yes, that is true. Okay, so 65,000 greater than 40,000. Yes, that is true. But the NOT operator over here will flip that particular Boolean logic. Okay, so it will now make that to return false, which means now if we run this query over here, we will get an opposite of what we got previously. So if I execute that one, you now see we are getting an opposite. So the salary 35,000, 38,000, and 36,000. And then now we have the OR operator. So for the OR operator, if any of the conditions evaluates to true, then that particular record will be selected. So you can say here, select all the employees whose city is Nairobi or their salary is anything above 40,000. They are anything above or equal to 40,000. So it doesn't matter if any of these conditions is met, then that particular record will be selected, of which I believe for us is going to be a lot of those records. Okay, as you can see, it's almost all of them, and it's working perfectly fine. Do we have any questions on that particular point?
Yeah.
Yes.
Go back to the end.
The end operator, yes.
What if one condition is not, I want to see the answer.
Well, if one condition is not met,
Yeah.
like, okay,
Let's say the salary, like it,
80,000. Yeah, so
I'm not, so they make it
90,000. 90,000. We take that, we don't get any records back. So there are no records. There are no records that match this condition over here, where the city should be equal to Nairobi and the salary should be greater than 90,000. Yeah, so if we bring back the OR operator, so for the OR operator is 8 of them. So if you earn a salary of above 90,000, congratulations, you're in. If you come from Nairobi, congratulations, you're in. But if it's false for both of them, okay, you don't come from Nairobi and your salary is not greater than 90,000, then you're out. So if we execute that query, you see we get a bunch of records here. Okay, you can see for the first one, it was selected because the salary is greater than 90,000. For the second one, all the way to the last one, they were selected because the city is Nairobi, even though the test for the salary was pending. Yeah, and I think for the not operator, we also understood this. Do we have any questions after this point? Okay, next let's look at the between operator. So the between operator in SQL Server is used to get values within a range. Okay, so generally we use the between operator in the where clause to get values within a specified range. And then you need to understand one thing, that the between operator supports, it only supports the and operator. And maybe it makes sense. Okay, give me all the employees who earn between 50,000 and 90,000. I think it makes perfect sense. So the between operator supports, the between operator only supports the and logical operator. So for example here, we can say we want to select all the employees who earn anything, between, let's say we want to select all the employees who earn between, I don't know, 30,000 to 50,000. Okay, so you can say here, where salary between 30, 1, 2, 3, and 50, 1, 2, 3. Okay, so select everything from employees where the salary lies between these two ranges. The salary is between 30,000 and 50,000. And if we execute that, you now see we are getting all the employees you are getting, their salaries are between 30,000 and 50,000. All of them. Okay, so that is the between operator. And remember, guys, you can always use the not operator to flip the Boolean logic. So if we say here not between 30,000 and 50,000, then you end up getting all the employees who are outside of this range. When we execute that, you see now we're getting all of those employees who are outside of that particular range. So the thing is that if anything returns true here, if a record returns true over here, then we have the not there waiting to flip that particular Boolean. So if it returns true, the not operator flips that to be false. If it returns false, the not operator flips that to be Turns out to be true. So that is the between operator. It's used to select the records whose particular column falls between two ranges. Okay, you can see here between 30,000 and 50,000. And it supports only the AND logical operator. I believe if you try to use the OR logical operator over here, it will not make any sense. Okay? In fact, if you try to execute that, we end up getting an error. So this between operator, it works with only the AND operator. Okay? So this is an equivalent of writing. This is similar to writing select everything from employees where the salary is greater than 50, 1, 2, 3, where salary is greater than 50,000 and the same salary is less than, sorry, it was 30,000. 30,000 and the same salary is less than 50, 1, 2, 3. Will this really work? Let me try it. Let me see if it is going to work. Greater than or equal to. Let's see if that is going to work. Yeah, you see it works. But I think we all agree that the first one is a bit more cleaner than the second one. Yeah, so the first approach is cleaner than the second approach. If we connect all of them, you'll see basically the same records being returned. So that is the between operator. And then, okay, not between, we've already looked at that. We've already looked at the not between. The next one here is the in operator. So the in operator is used to search for a specific value that match any value in a set of multiple values it accepts. Okay, so generally we use this in operator in where class to compare column or variable values within a set. With a set of multiple values. So for example, the query below will return all the employees who are from either Mumbai or Washington or Nairobi. So yeah, I think it makes sense. Let's say you want to get all the employees who are from either Mumbai or Washington or whatever it is you're looking for. You could have multiple or conditions, or you could use this in, and then you provide a set of values that you want to check from. So in this case, you can say select. Just a second. Select everything from employees where the city is in, and then you provide here your values. So if I say here you want the city to be Nairobi, and then let's say Mumbai. So you only want all those employees to come from Nairobi and Mumbai. So you can see I'm providing a set of values to use for comparison. So select everything from employees where the city in Nairobi from Mumbai, and when we execute this, you see we only get employees whose city is either Nairobi or Mumbai. Okay, and then the not in operator, I think we all know what the not operator does. So if you say here where city not in Nairobi from Mumbai, I think we all know what that is going to do. It's going to select all of those employees who don't come from Nairobi or from Mumbai. And that makes perfect sense. And then finally, we have the like operator. So this is one of the most frequently used operators in SQL Server. So the like operator in SQL Server is used to search for a character string with a specified pattern using wildcards in the column. So I know we need to cover regular expressions in JavaScript, but it's something that you guys will go look at your own time. The concept of regular expressions. So regular expressions are used for pattern matching in a string. Okay, so let's say for example, you want to get all the employees whose names start with DE. Okay, you want to get all the employees whose names start with DE. How do you get all of those employees? Well, you're supposed to use regular expressions. So that is where this like operator comes into play. So the like operator is used to search for character string with a specified pattern using wildcards, in that particular column. So for example, let us look at this percentage wildcard. The following SQL query will return all employees whose names start with character P, followed by any string of characters. Okay, you can see here, select everything from employees where full name like P, and then followed by any string of characters. You can imagine, for example, the user is searching for a particular record. So when they type letter P in the front end, you can make some sort of a database, some sort of a request to your backend, and then the database can make such a query, okay, and return the records that match that particular pattern so far. So when you use this percentage wildcard, okay, it's like telling SQL server or SQL, you want all the records where the full name starts with letter P followed by anything afterwards. Let us copy that and use that in our query so that you guys see what we're talking about. So select everything from employees where your full name, like, and then display percent. By the way, guys, at your own time, please go look at regular expressions. They are a bit scary. They even scare me myself. I'm not the biggest fan of regular expressions, but that doesn't mean it's supposed to be the same case for you. They are quite fun though. So if I try to execute this one over here, I execute that, you now see we're only getting the employees whose first name starts with letter P. Okay, we can even start here with letter J, and this is going to select all the employees whose full name start with letter J followed by any number of characters. So you can see here John Doe, Jackie, Manny, Jen, Klaus, Jacob Otieno, and Julia Martins. Okay, so yeah, that is what they do. Let us continue looking at more of these patterns. We have that first pattern. The next pattern is this underscore, which will represent a single character in that particular expression. Okay, so you can see here, for example, if we pass here where your full name, like, and then we pass here underscore 1, 2, 3, 4. So that is 4 underscores. So we are telling SQL server over here, we want all the employees whose full name has only 4 characters, of which I believe in this case we don't have such an employee. Okay, so if we try to execute that, you will see we don't have such an employee. But I believe we have an employee whose full name has 7 characters. So 4, 5, 6, 7. If we try to execute that, still nothing, maybe one more character here. So 8 characters. Yeah, you can now see we're getting here John Doe. So an underscore represents a single character. So first character, second character, third character, fourth character, fifth character, and so on and so forth. Okay, you can see it looks like a regular expression or something in those kinds. The next one here is this bracket symbol, which indicates a set of characters in that particular expression. Okay, so you can see, for example, here, select everything from employees with a full name, like, and then we have a set of characters. So here we're saying we want all the employees whose full name starts with either letter J or letter H or letter K or letter U, and then followed by any number of characters afterwards. So if we copy this and we try to use it here, okay, so select everything from employees where the full name is like this pattern, starting with letter J, followed by letter H, K, U, and then followed by any number of characters afterwards. And if we try to execute that, you see all the employees you are getting, their full name is starting with one of those characters that we have specified. Okay, so very powerful when it comes to pattern matching. And then if you want all the characters from letter A all the way to letter Z, you can specify something like that. Characters A all the way to Z. Okay, this is especially powerful in usernames. You know, for example, in Instagram, people have very weird usernames. Somebody is called, I don't know, underscore, whatever that is. Okay, somebody has a username like $sign underscore percentage, I don't know, KE underscore kiddo, very weird usernames. So, okay, so in such a case, maybe let's say you only want all of those users whose username starts with something alphabetical, then you can use this order here, letter A all the way to letter Z, and it will work perfectly fine. Do we have any questions at that point? Any questions? Okay, let us take another short 10 minutes break or 15 minutes, and then we should be back here by 11:25. So, quickly rotate into. Please be reminding me to share my screen. And then tell me answer to watch. Okay, just. Okay, I want us to look at SQL joins. So joins is a fundamental concept in SQL, and it applies to all relational database functions. It's an SQL standard. So the SQL server joins are used to retrieve data from two or more related tables. Okay, I think you guys went through the database normalization over the weekend, and when we talk about two or more related tables, I believe you know what we mean by two or more related tables. So in general, tables are related to each other using the primary key and the foreign key, and I'm going to show that to you in a short while, using the primary key and foreign key relationship, but it is not mandatory to do such a thing. I mean, it's not mandatory for them to be related using a primary key and a foreign key. Now, the tables involved in the joins must have a common field, and based on that particular common field, SQL Server joins retrieves the records. So we have the following types of joins. The first type of join that we have is the inner join. Okay, so joins can be classified into the following three types. The first type of join that we have is the inner join. After that, we have the outer join. Okay, of which the outer join is further classified into left outer join, right outer join, and full outer join. And then after that, we have the cross join, and then the self join. So let us go through them one by one. By the way, the moment we do the inner join, we're going to get an idea behind what we mean by joins in SQL Server, and we're going to get the idea behind, splitting data into tables. I mean, okay, whatever that is. So the inner join in SQL Server is used to return only the matching records, or rather only the matching rows from both tables. Remember again, guys, it's basically the concept of combining two tables. I know this doesn't make any sense yet, but the moment you finish up with this example, you will see what you're talking about. So the inner join in SQL Server is used to return only the matching rows from both tables involved in that particular join by removing the non-matching rows. So it will return only the matching rows from both tables involved in that particular join by removing the non-matching rows. So it basically returns only the rows where there is a match in both tables. When you perform an inner join in SQL, Server, you're essentially looking for the intersection of those two tables. Again, we're going to look at that now in a few while. So in fact, this is the syntax to performing inner join in SQL Server. So you select the column name or the column names from the first table, and then you inner join the second table on a particular similar column. Okay, so select column names from a particular table, inner join the second table on a particular field. Okay, so inner join and join are basically one and the same thing. Okay, so inner join, when you say inner join and you say join, they're basically meaning one and the same thing. It's like synonyms. So inner join of join, any of that is going to work. Now this is the example we're going to use to understand joins in SQL Server. Okay, so let us understand how to implement inner join in SQL Server as an example. So we have this company table. As you can see, this company table, it has this company ID and company name. So company ID 1 and the company name is Dell. Company ID 2 and the company name is HP. Company ID 3 and the company name is IBM. And then company ID 4 and the company name is Microsoft. Okay, so after this particular company name, we have the candidate table. I mean, after this company table, we have the candidate table. So the candidate table, you can see the candidate is ID 1, full name 1, and the company ID for this candidate is 1. So this 1 is related to this ID company ID 1 on this company table, which means this particular employee works at Dell. Okay, we have Pete over here with ID 2, with company ID 2, which means Pete works at HP. We have Steve with company ID 3, which means that Steve works at IBM. Okay, and then we have another Steve over here who basically, as you can see, is null. So this team over here, he doesn't work in he works in neither of the companies. Maybe he's unemployed or something in those lines. And then we have Ravi. Ravi works at a company with ID1, so that is there. And then we have Raj. Raj works at a company with ID3, that is IBM. And then we have Kiran. Kiran doesn't work in any company. We can see company in this null, which basically means maybe Kiran is unemployed. So this is the table for, this is the SQL query for creating the company table. And as you can see here, we are inserting the value and then selecting everything from company. Just make sure that everything has been done successfully over here. So copy this. And I think you all know by now what is happening over here. Creating the table and inserting the data and selecting everything from that particular table to understand what is happening. So when we execute that, as you can see now, we have our company table, which has been inserted successfully. And then we have the candidate table. So copy that, and then also paste it here. And we finish by saying, select everything from candidate. And when you execute that, you see the candidate table has also been created. Okay. So now we want to perform a join between these two tables. So maybe it is a client, or sorry, not maybe it's a client or a particular user requesting this information. So the inner join joins, as you have said, joins are joins are basically performed on some sort of a similar column. Remember when you were discussing what we mean by joins some few seconds ago, we were saying in general, tables are related to each other using primary key and foreign key relationship, but that is not a must. It's not really a must for tables to be related using a primary key and a foreign key relationship. Okay. So the thing is that the tables that are being involved in a join must have a common field. And when we talk about a common field, we're not talking about the name of that particular field. So somebody might think that you must have a field called, let's say, company ID in the first table and a field called company ID in the second table. No. When we talk about a common field, we're talking about a common field in terms of the data type. So the data type of that particular field must also be similar to the data type of the field on the other table. Okay. And now we are saying that in a join, we select the columns from the first table. So we select the columns from the first table, and we use inner join. We use this inner join syntax on the second table, and then we provide here the condition using this on using this on statement. On table 1 dot column name is equal to table 2 dot column name. Okay, I think we have that here when we perform the joining. I'm going to explain why we need this. Okay. So you can see here, select candidate ID, full name, company ID, company name from the candidate table, and we are inner joining the company table. So inner join or join, when you use the join keyword or inner join keyword, it's basically one and the same thing. So we are selecting all of these columns from the candidate table, and we are joining the what? From the candidate table, and we are joining the company table on the field of company ID on the candidate table is equal to the company ID on the what? On the candidate table. Here. In a join company exactly. On company ID on the candidate table, is equal to company ID on the candidate table. Okay, so you can see C stands for the candidate table and CO stands for the company table. So what you're trying to say is this: when you want to perform an inner join, this is how you do it. Select and then you specify the fields from the first table. Okay, so our first table here is the candidate table. From the candidate table, we want the candidate ID. Okay, we also want the full name. Maybe those are the only two things that we want. So select the candidate ID and the full name, and then we want this to come from the candidate table. So we want those to come from the candidate table, and what you want to do Okay, we want to inner join, we want to perform an inner join on the company table. Let me just select first of all the company table so that you guys see what you're talking about. If we say here, select everything from company. Just a second, guys. So if you say here, select everything from company, you can see for the company, we have company ID and company name. So you want to inner join the company table. We want to inner join the company table on, and then you specify the fields that are, or rather the columns that are basically that will basically be used for the joining. So if we select both the data from both of the tables over here, you will see that the common column is the company ID column. So the company ID column is what is common on both tables. So inner join company on company ID on the first table, of which you don't know what table that is equal to the company ID on the second table, of which again you don't know what that other table is. And that is why now this aliases come into play. Okay, that is now why you will see people doing something like this. Okay, let me just try to change this size over here. That is the reason why you will see, I don't know what this syntax is, where people do ca.candidate ID, ca.full name. I don't know if it's aliases, if it's variables, I don't know what that particular syntax is. Okay, but that is the syntax that we use to differentiate which column is from which table. Okay, so if I say here, for example, select CA, I can just use CA to name candidate table. So CA.candidate ID, CA dot full name from candidate CA. So that is from the candidate table. And I want to inner join company, and then I can just give it a name like CO to mean company. Okay, so we are inner joining company CO on CO. Remember now CO is what we made is what we use to make the company. So CO.company ID is equal to CA for the candidate now dot company ID. I know it's still not making any sense, but I don't know. As time goes by, you guys will continue running this syntax. So we are selecting here the CA.candidate ID, CA.full name from candidate CA. So you can see we're naming the candidate table over here as CA, and we are naming the company table as CO. That way, even when it comes to joining these two fields, when we say CO.company ID, then we know where this company ID is from. Because you can see in both of these tables, if you look at both of our tables, just a second, if you look at both of our tables, we have that company ID column. So it's a good idea to differentiate them in this syntax, which I'm not sure what that particular syntax is. And before I forget, I also want the company name. Okay, I also want to select the company name. So because our company is called CO, I also want to select here CO dot company name. So if we try to execute this query, maybe it will now make sense. I hope it's going to work. Yeah, you can now see we have joined those two tables. Okay, so you have joined those two tables based on a similar column, and the similar column was the company ID. The similar column was company ID. So yeah, the join is successful. So you can see Ron is working at Dell, Rav is working at Dell, Pete is working at HP, Steve is working at IBM, and Vlad is also working at IBM. Again, this is what we had. Where are those two tables? These are the tables that we had. Okay, so this was the candidate table, and then this was the company table. And I know you guys are asking,